Good morning, everyone. Good morning, and welcome to the Region 1 Maths Team Grade 4 workshop. And we welcome all our students, all our teachers right across Region 1. And we expect to have a great time. But before we go into the actual workshop, or actual time with you as students, we want to just offer a word of prayer for direction and for the Lord to just bless our time. So let us pray. Heavenly Father, we thank you that you are the one who gives us the ability to teach and to learn. We ask you, Lord God, by your Spirit to take charge of our workshop today, cause it to be fruitful, cause that what is imparted will be clear to our students, that it will give our teachers additional strategies to use in the classroom, and cause us, Lord God, to have a great time over this next hour and a half or so. Let your will be done and let your kingdom come, and cause us, Lord God, to come away from it being much better off. In Jesus' name we pray, amen. So once again, good morning. My name is Carol Harris. I'm one of the math coaches with the Region 1 Mathematics team. Along with me, presenting for the most part will be Mr. Giovanni Lime, and we will be working together to present you a key number concept, which is fractions. Just to set some protocols, set some housekeeping rules so that we all know what's taking place. First thing I'd like you to do is to type in the chat which school you're from, so we can get an idea of which schools are attending. And we'd also like for you to make sure that when we ask questions, you answer. So you may answer by typing in the chat, because it's going to be a little bit difficult to have all the mics opening. So type in the chat what your answer is when we ask the questions. And if you're not sure, that's fine too, because that's what we're here for, to learn. So that's the main thing. Secondly, we'd like for you to, at the end of the workshop, you're going to be asked, just kind of give us an idea of what you thought of the workshop. Was it useful? You give us a score from 1 to 5, 5 being perfect. We love that. 5 for top score, 1 being no, come back again. We'll and come again, sir and miss. So we wanted to score that at the end of this. Just give us a number and get an idea of where you're at. And if you have any questions, just share it with us. So have a great time. So we're going to go right into it. So I love the names coming in from the schools. So I see Crichton, I see St. Peter, and Paul, and welcome to all our schools coming in. And so what do we want to achieve for today? We want to encourage our students by the end of our time today for you to be able to use benchmark fractions to not only estimate, not only to
Harris, I think you're muted.
But that's fine. Thank you very much, Mrs. Darby. So what we want to do from those two things are to compare fractions and to order fractions with different denominators. And if at any point you're not hearing me, you just let me know, please. Thank you very much. I see Crichton was telling me, but I didn't pick it up. So let's go right into it. Great. So firstly, let's start. Where shall we start? Let's start at the very beginning. It's a very good place to start. So before we set the tone, we want to set the tone by getting into our vocabulary. We want to get, because if you can't understand, if you don't know what words mean. So let's start by looking at our vocabulary. What are some of the things we need to be clear on? The first thing we want to be clear on is what is the numerator of a fraction. What is the numerator of a fraction? Well, it is something that gives us the number of parts that will be named or used in the given situation. So that's our numerator. So the number that we're going to be talking about, what we're going to be speaking about at a given time. But even more important is the denominator, because that denominator tells us what's the family that the fraction is going to be coming from. It tells us the number of equal parts into which the whole is going to be divided, and it allows us to name the fraction. So let's think about everyday life. My name is Carol Harris. And for most people, not everywhere, some people, they will use that. You name by your dad's name in most cultures. So all of us who are the same father, as we say in Jamaica, we have the same surname. It's the same thing with a fraction family. If your whole is divided into 3 parts, 3 equal parts, you call it thirds. If it's 4 equal parts, you call it quarters or fourths, and so on. And typically the fraction name uses ordinal numbers. So eighths, fourths, fifths, and so on. Next, we want to look at what is a proper fraction. What exactly is a proper fraction? A proper fraction is one that has a situation where the numerator is smaller than the denominator. So we're just going over some key things that we want for us to know and have a clear understanding about them. So we look at the numerator, the denominator, what is a proper fraction? But you know we have prefixes, don't we, boys and girls? When you put a prefix like this or im, if a proper fraction is one that has a numerator smaller than the denominator, what do we think the improper fraction would be? Before Sir puts it up, let me see what you think it is, even if you didn't know before. Type in the chat and let's hear what that would be. What do you think an improper fraction is? Or remind us, tell your classmates what an improper fraction is. Quickly, I don't say anything yet. What's happening here? Let's see them shooting us, coming right back. Oh, some of you might be in your classes and not at an individual device. So tell Miss or Sir to type it in the chat. Miss, we know that. So what's an improper fraction? An improper fraction, let me see, a fraction whose numerator is bigger than the denominator. Thanks, Quaid. I don't know if it's Quaid. Thanks for that one. It's a number, a fraction rather, where the numerator is larger than the denominator. That is typically accepted definition for an improper fraction. The numerator is bigger than the numerator. Great, thank you for that. So that's an improper fraction. Let's move on to some other vocabulary and some signs that we need to be aware of as we operate in this space. If you're going to compare, you're going to be able to know what are some of the key signs we'll use when you're comparing fractions. Firstly, what's the first one we're going to look at? So Crichton mentioned that the numerator is bigger. And is it Quaid? A couple of you mentioned it. And so we know about that. How do you know? How do you show that something is bigger? Let's look at some of those signs and symbols. When something is greater than another, it has a larger quantity, a larger value, then it's going to use the term greater than. The greater than symbol looks a particular way. Well, we put it that way. It's that way because we typically read from left to right. So the greater than has the larger open part to the left. And that's telling us that the value that is greater is to the left. And typically for our signs, the part that is open always goes to the larger value. The part that is pointed goes to the smaller value. So the greater than tells us that this is what we're talking about. The greater than symbol shows that whatever is to the left is larger than what is to the right. Great. What about less than? Of course, it's going to be the flip. It will look the other way. It's going to, well, I forget that my camera is going to be reversed. So the less than sign will show you having it less than. So to the left, the smaller value to the left, the larger value to the right. And of course, when they're equal, they have the same value. There's none that is greater than the other. So, for example, if I have 3 things, I know that 3 is less than 5. If I have $300, obviously I have less than when I have $500, right? So 3 is less than 5, or we could also say that 5 is greater than 3. So the symbol, we would typically read 3 less than 5, but that statement is also telling us that 5 is greater than 3. So be aware of that, boys and girls, that though I can say 3 is less than 5, but there's nothing wrong with saying that 5 is greater than 3 because the statement is true in both ways. Great. All right. So let's talk about the pizza, sir. What do we know about this pizza? All right. So we know pizza nice, don't it? For most of us. And if you're not a pork eater, go for the vegetarian one or just plain cheese. So let's talk about some pizza. All right. So let's talk about Mr. Joe. Meet Joe. He's a pizza man. And Joe has its pizza. So we're going to talk this pizza that Joe has. We're going to let's look a little bit at this pizza and see how this pizza could teach us something about fractions. Now, how many slices do you see here? What do you think? Based on how it looks like it is sliced up. Type in the chat for us. What do you think? How many slices do you see? Okay, Quaid. says he sees 6. Great. Natasha says 6 as well. And Mr. Neil, Sarah, lots of persons are saying 6. And I think I see 6 as well, 6 slices. So a number of you are saying 6. And so we could say this pizza is cut into 6 equal parts. And what would that 6 tell us about if we were to create a fraction regarding this pizza? What would that 6 tell us? Tell me what you think it would be. What do you say, based on what we've said, what would that 6 tell us about something that we could say about this pizza? It tells us the denominator. Fantastic. Thank you for that, Natasha. It tells us the denominator. So we could say the pizza is cut into 6 equal parts. And that 6 would represent the denominator of the fraction. Fantastic. Good stuff. So we're on the track. So let's say I took a piece of that pizza. And so Jim took a piece and he said, I had half of the pizza since there are 2 pieces. There are 2 pieces. I ate one and then one is left. Tell me if you agree with what Jim said. Type in the chat and tell me, do you think Jim is right that he had a half of the pizza? What are your thoughts on that? Type in the chat as always, or as we want for you to just give us that feedback. Do you think Jim is right when he says, no? I see that no. Lennon says no. I think I saw somebody saying yes. All right. Some say no, some say yes. When you say the no, tell me why you say no. Right, so Kazia, tell me why you say yes. Let's go to Kazia first. Do you want to tell us why you say yes? Or if you've changed your mind, why you've changed your mind? So let me hear from a no and a yes, why you think it is not right. But Jim said, made an incorrect statement when he says, okay, Kazia said she changed her mind. Why did you change your mind? And that's fine. You can rethink your answer and say, oh, now that I think about that, that's not really what I wanted to say. All right, St. Patrick's Primary, a number of you are saying no, but I don't hear why you're saying no. Tell me about that some more. Why do you say no? Type in the chat quickly why it isn't that Jim ate 1/2. There is a turn, okay. Could tell me a bit more about what that turn means, St. Patrick's Primary. So there is a turn. Why does that make it not a half? Why was so quiet? Talk to Miss Harris. No, man, I don't want to be alone here. Tell me why you say it's not a fraction. Share some more with me why you say it's not a fraction. Give me some feedback. Talk to me. There's 3 more slices, okay. And what's the significance of there being 3 more slices?
Good morning, Miss.
So good morning. No, because he took out 1 of the 4. So if he took out 1 of the 4, Omar, 3, okay. All right, I'm seeing a number. I'm seeing several numbers coming up here. But the numbers don't tell me why it's not a half. Talk to me some more, man. Put some more meat on those answers. Put some good meat. Because it's not a half. Well, why is it not a half? Give me some more. Put a bit more on that, man. Because it's not a half. It's 3. How did we say we know the fraction? So how do you know that, it's not a half? All right, so tell me a bit more what you're thinking. So it's not a half. It's not a half. Tell me some more. Oh, I see some more message. Let me see if he took 1 further from the whole, which is 6. All right. Well, the whole at first was 6. We have a slightly different pizza now, but did he take a half of this pizza? Okay.
Yes, Miss. Yes, Miss. He took a piece 1/2 of 1/2.
Right. And you agree with him, but why do you say he took a half? That's what I wanted to tell you. Some of you are saying no, and you're still not telling me why you say it's not a half. Give me a bit more. What makes you say it's not a half? I think it's a half because it's 2 pieces. Convince me that it's not a half.
It makes it a half because it's when you cut it in half, it's 2 pieces, so it's technically a half.
Oh, it's technically a half because it's 2 pieces. Tell me about the 2 pieces. Do the 2 pieces look this?
The 2 pieces.
3 is a half. Let me add, Gianna says 3 is a half, but I want to ask you something. I don't know who spoke a while ago, and we're allowing you to tell me something. If you
Miss, I'm the person that's talking right now. My name is Aiden.
Aiden, okay, Aiden. So Aiden, tell me something. If you and your brother or sister were sharing this pizza, and your brother took what's left and you had the piece that's taken out, would you be happy with that? Do you think that would be fair?
Pardon me, miss?
I'm asking you, Aiden. So you see the piece that is away from the pizza? Suppose you and your sister or brother were sharing the pizza, and your sister or brother took the piece that's left, and you had the piece that's taken out. Do you think that would be fair?
No.
No, okay. Why is it unfair?
Because they take the whole pizza and I only get 2 pieces to myself.
You got 2 pieces to yourself and they took the whole. Wow. But boys and girls, I want to think about one of the things about fractions. What did we say the denominator told us? What did they tell us the denominator told us? It's not a half because the pizza is not in 2 equal parts. Natasha, you think you're onto something very key there, Natasha. Natasha says it's not a half because the pizza is not in 2 equal parts. Fantastic. Because if my brother took that piece and gave me the other little piece, I would not be at all pleased because it's not equal. And we said it's a half. If it's a half, the 2 tells us that the whole has been divided into 2 equal parts. 2 equal parts. Are those 2 parts equal? No, they're not. They don't look equal at all. They've not been shared equally. So I see someone telling me a half of 4 is 2, not 1. But we don't even have to go that far. So we're not going to spend too much more on this. The key is to recognize that the whole must be in equal parts. So he did not eat a half at all. So let's take it a little bit further now. So how much of a whole pizza did Joe eat if this is left? Or Jim, whatever his name is, a J name. How much of it did he eat if this is left? 2/4, okay. He ate a half. And we're saying a half. Why? Well, Natasha, you said it earlier on because now the whole has been divided into 2 equal parts. He took one of the parts and the other is left. So it's now a half. Great. He ate half. He ate 2 parts. 2 parts of how many? Well, I don't. It's a half. Great. Thank you for the feedback. He ate 2 out of the 4 parts, so he ate a half. Great. So how do you know it was a half? Someone told me it's 2 out of 4. Is there any other reason that he said it's a half?
I am Kasmar Petin Donaldson.
Is there any other reason that you'd say it's a half? How do you know it's a half? I know one person said he had 2 of the 4. So that means that he has 2 equal portions. 2 out of 4, so 2 You ate 2 pieces and another one left 2 pieces were left. Okay. I think we can work with that. We know that we took half of what was there. Great. All righty. So he has taken a half of the pizza. Now, why are they teaching me this fractions thing? Where will I see fractions again? Am I gonna see it ever again? Sure. Let's look at some ways we're gonna see fractions again. All righty. So if somebody's building a cupboard for you, they're gonna need to know fractions, because many times we're gonna be measuring, we're gonna be having to measure the exact amount of wood that is to be used. That might be important another way. So tell me some other ways you might think you're gonna use fractions other than what you see in this picture. Let's type in the chat and tell me, what are some other ways that we could use fractions in real life? Where am I gonna see fractions again? Tell me what you think.
Miss, I think that the other way that you could use as fractions, you could use like like if you were on a computer and you cut it in half, that's and you decided to cut the cake into 5 halves, and you gave 1 half to your sister, 1 half to your brother, and 1 half to yourself. So that would and 2 would be left. So the denominator would be 3 and the numerator would be 2, because that's how much is left.
All right, let me see if I can get what you said a while ago. And I'm not picking up the name, so what I'm gonna ask you to do, if you wanna share, raise your hand. Oh, it's Aiden again. Oh, thank you, Aiden. So Aiden, let me ask you something. If it's a half, what's your denominator?
Or denominator would be, it would be 3.
For a half?
Oh, it would be 1. It would be 1.
For the denominator of a half? Anybody agrees with Aiden? Would you say that the denominator is 1 for a half?
No, miss.
It's gonna be what? Okay, I see a raised hand.
2.
The denominator will be 2. Is it Quaid? So if
Yes,
you want to
miss.
speak, just a second. If you want to speak,
Nathan.
just a second. Pause a minute. If you want to speak, there are a number of you online. So if you want to speak, I will need for you to raise your hand first, and then don't open your mic immediately. Raise your hand, and then I'll say, okay. So all right. Aiden, do you still think that? Do you still agree that the denominator? So you're thinking that the denominator is a half. For a half would be 1. Kazia, tell me what you think.
Yes, miss, I agree with that.
You agree that the denominator will be 1 for a fraction of a half. All right. What did we just talk about a half a while ago? Kazia, tell me some more about your 1 being the denominator. All right, we're talking about the denominator for a half, just for a moment, before we go a bit more into some of the ways you see it in real life. Don't open your mic until we ask you to, please. Is it Nathan? Nathan, go ahead and talk for me, please. What do you think?
Okay, miss. So, like, I would think if the 1 will be like our denominator, I would think like it would be like a fraction.
If 1 is the denominator, all right. I didn't hear you so well because you're a little distorted.
Yeah, turn it long way,
Natasha? Natasha, you want to share with us what would be the denominator is a half?
Mister, I can't hear anything. Mister, other kids on. Oh, mute your mic.
All right, so maybe I'll have to. So Natasha, you're about to tell me about when it's a half.
Mute it.
Natasha, you're about to tell me about the half.
The half would be the fraction would be 1/2, and the denominator would be 2, which representing the half, which is 1/2.
And the denominator is 2 because I've done what? What have I done to make the denominator 2?
Because a half is 1/2.
Okay, that's how I write a half, 1, the fraction bar and 2. Suppose I'd shared it equally for 3 friends. Would I write 1 with the fraction bar and 2?
No, you wouldn't.
How would I write it?
1/3.
Okay, so with 3, that's in the denominator this time. All right,
Yeah.
so the 3 tells me because I've shared my whole into 3 equal parts for my 3 friends, each of us, my friend and myself and 2 other friends to get the same amount. Good. All right. So if I'm sharing with my friends and I want us to get it fairly, that's one way I'd use fractions every day. What's another way? Have you ever noticed when, oh, somebody said to me, St. Patrick's Farm, we talked about on the clock. Tell me a bit more about how you see fractions on the clock.
The reason how you
And I see someone else from St. Patrick's talking about building materials, how I'd shared using my St. Patrick's Farmer mentioned about the St. Patrick's Farmer. Could one of you share for me the 2 ways you've talked about the So Miss
Good morning.
Sarah from St. Patrick's, could you just allow one of them to talk a bit about the how they see the fractions, please? In real life, talking about the building materials and on the clock.
Is a whole fraction. The fraction on the clock, whole fraction. The fraction.
All right, I didn't hear St. Patrick's at that one. All right, I really wanted to hear a bit more about the clock, but I'm not hearing you so well. What about well, let's talk a bit about the clock. Sometimes we talk about a quarter past the hour. Is that so? Where did everybody go?
Miss, we're right here. We're right here. We're right here. Hold the phone.
Oh, but you got so quiet, so quiet, so quiet. So if it's a quarter past 4, what does that mean on the clock? Tell me what that means if you talk about a quarter past 4 or half past.
Half past 4 is like 30 minutes to, example, 30 minutes to 5.
Okay. And because 30 minutes represents what part of the hour?
The 30 part of it will be half of the hour.
Okay, and so we talk about half past because we've gone a half of the hour. Great.
60 minutes. Because 60 minutes makes an hour. So it's
correct.
technically.
So since 60 minutes makes an hour, when I've gone 30 minutes, I've gone a half of an hour. Fantastic. Thank you for that feedback on the clock. St. Patrick's, we're going to talk about some, how many of you have ever heard said, oh my goodness, the tank is almost empty. Tell me about that. You ever heard mommy or daddy talking about that in the car?
All the time.
All the
Miss, can
time.
you repeat that?
Have you ever heard mommy or daddy when you're driving the car? Oh my goodness, the tank is almost, what does the E mean?
Yes,
Let's
Miss.
What does the E mean?
Empty. Miss, my mother
Empty.
always do
Empty.
that around me. That's fact.
Miss empty.
E means empty. All right.
Empty.
So when something is empty, what's happening? Is there anything in it? How much is in it?
Nothing.
Zero. Okay. So
There's
that is
nothing.
when the tank is empty, it is Z. What about when it's F? At F?
Full. Is it
Full.
full?
So I have a whole tank. My tank is full, so all of my tank is full. Great. So a full tank means that I have a whole tank full.
Miss,
And when
would
it's
you?
empty, I have nothing. Great. So that's another everyday use of fractions.
Yes, miss.
Anybody like Christmas cake?
Yes, miss.
Who does not like
Miss.
Christmas cake?
So how you think you're gonna make the Christmas cake well? You have to
If
use
somebody
fractions.
Miss, if somebody does not like Christmas cake, I don't know what are they?
Excuse me,
Okay,
miss.
so let's focus on the cake now. So
Yes,
if we
I
like
love
cake,
Christmas.
all right, so let's talk about it. So if we're gonna make the Christmas cake, it's gonna use what we call a
Excuse me, miss.
recipe. And the recipe is gonna use fractions very often. We're gonna have to use a certain amount of flour or salt, and we'll have to find fractions of these things in order to measure it and make it work well, okay? So fractions, those are some of the ways we're gonna use fractions in everyday life. Carpenter, the mason, the cook, the chef, all of these persons, the pastry chef, all these persons are gonna use fractions in one way or another. All right, so now, let's quickly look at now, what is a fraction?
Miss, a fraction is
Remember to raise your hand before you speak, Aiden. I love the participation, but I would love for you to raise your hand first.
Miss, how do you raise your hand? I'm confused. Should I turn on my camera and just raise my hand?
Okay, so you're gonna look on that. Do you see a part that says more?
Yes, Miss.
All right, you should see something there for reactions. And in the reactions, you should see raise hand. Do you see it
Miss,
now,
a
Aiden?
fraction is something that can be divided.
Remember to raise the hand so I can acknowledge you. So who came first on that one? Was it Nathan?
Miss.
Oh, Natasha. Natasha, could you tell me what you think what do you understand a fraction to be?
A fraction is
equal parts of a whole.
fraction is a part of a whole.
A fraction is a part of a whole. That's you, Natasha or Nathan?
A fraction is an is a part of a whole.
Fraction is equal.
Think about what you're saying and then speak.
That too. Think about what you're saying. Raise your hand, and then I will ask someone to answer at that point. So I see, is it Galaxy? Kelsey Marie, is that who I see there?
A fraction is a part of a whole.
It's a part of a whole. So do you remember
Yes,
that?
miss.
So what's supposed to be special about the whole before I can talk about the parts? We said something very important about the whole before we talk about the parts that we take from the whole. what's the part that we said was so what was the important thing we said about the whole? Can't leave out that part, and that's very important. Gianni, what was the important thing we said about the whole? I see your hand up, Gianni Prendergast.
It says equal.
It's equal. That equal is an important word, but what have we done with the whole? Anybody else wants to finish off what your friend, your classmate just said?
Fraction is an equal part of a whole.
Fraction is an equal part of a whole. I'm hearing that keyword equal, so I'm going to work with that for now. So a fraction is a number that represents equal parts of a whole. So most of you got that general idea that equal parts is very critical. Fraction is a number that represents equal parts of a whole. Great. So quickly type. What fraction is represented here? What fraction have we represented? 2/4. No, you don't just type in the chat. For now, just type in the chat, please. 2/4, great. 2/4, great. Thank you. What about this one? What does this one represent?
1/4. 1/4.
Just type. 1/4, great. But I didn't ask you which part I was asking about. Suppose I didn't ask for the shaded part. What would you tell me? The colored part. What would you tell me?
1/4.
1 out of 4th or 1/4 or a quarter. Suppose I ask for the part that isn't colored. The white part. What would you tell me? 3/4. Thanks, Wade. All right. Just what I've asked you to do now, so you're gonna go 1/4, 3/4. What about, so you're right, it would be 1/4. 1/4 that is colored this time, great. And 3/4 if we're talking about the parts that not colored, great. 1/4. What about this one? What fraction of it is colored? 3/4. 3/4 or 3/4. Great.
3/4.
So we've gotten the fact that a fraction is a number that represents equal parts of a whole. Great. So we're going to do this last part now, finish up reviewing. So for each of these, for part A, type, note on here.
Yes, miss, that's 1/2.
1/4.
So here's what I would like for you to do now. So you're going to type in the chat for me what fraction is shaded for part A. What fraction is shaded for part A? Let's see that those OMC, so let's see it happening. 1/2. All right. 1/2. So 1/2 is shaded, great. So I want to see you typing the chat for this section. Part B, so the denominator here would be, what would be the denominator? Type in the chat for me, what's the denominator here? 2, great. What about D, 1/4? Great, Nathan, I'm seeing that 1/4 because it's 4 equal parts. What about C? Some of you jump ahead and reach Fireman, 1/6. Great. D would be what? 2/3. Great. Quaid is on the ball today. Natasha says 1/4. for B, 2/3 for D. So we're seeing that we're looking at the number of equal parts that make up the whole. That's what tells us our denominator. It tells us the name of the fraction. It tells us the family from which a fraction comes, and that's what guides us with the name of the fraction. Great, I think we've gotten that part nicely, and so we'll press on. Again, I'm ready for you to type in the chat. Look at this representation of a flag. Well, it shouldn't be, it's a flag of Greenland, I believe it is. Greenland is where? Way up in the north, in the northern hemisphere, way up in the cold parts of the world. How much of this flag is red? Type for me, please. How much of this flag is red? We're going to just be typing for a little bit. B equal to 1/2. Okay. A less than 1/2. B equal to 1/2. Liana says 1/2. B. Lots of B's coming out here. Great. I think we're on the same page. B. D. Where did D come from? So Aiden, tell me about, oh, you meant to put D? Where did D come from? I'm sure that's a mistake, but I know you meant B. Great. I'm in full agreement that B, it is equal to 1/2. What did you use to guide it to know that's 1/2? Now, suppose we were to, at first, you might be looking at only one part, you might be looking at the rectangular part, but suppose we should have put all the red portions in one part. So the red part from the circle and the red part from the rectangle, you would see that all the red occupies 1/2 and all the white occupies another 1/2. So B is in fact correct. It's on 1/2 of the flag that is red. Great, you did well on that one, boys and girls. Equal to 1/2. It is in fact equal to 1/2. What about this rectangle? What fraction of rectangle is red? Tell me about that. Is it more than 1/2? Is it greater than 1/2 or more than 1/2? Is it equal to 1/2 or is it less than 1/2? What do you think? Johnny says 1/2. Anybody else has any thought on that? It's equal to 1/2. Johnny thinks it's equal to 1/2. Equal, Aiden says equal. Less than 1/2, Sarah says less. Eva says 1/2. Liana says less than 1/2. So I'm seeing a mixture of answers here. Less than 1/2, equal to 1/2. All right. I wonder how we arrived at our answer. How did we get to that answer? Some are saying less. Some are using even my symbol for less than 1/2. Less than what though? Less than 1/2, less than 1/2. Okay. Kazia is saying less. So the majority of the answers are saying less than. There are a few are saying it's equal to 1/2. And I'm glad nobody is saying that it's greater than 1/2. Because if you look at the picture, the white is obviously more than the red. So let's see, look at that a bit more. So less than, lesser, good. How would you have come up to that value that it is less than 1/2? Well, a while ago I just said, but then the white part is definitely looking more than the red. So if it's more, it can't be equal anymore because the white part bigger than the red part. But a more structured way, a more, what should I say, accurate, precise way that I could have done it would be to divide my shape, put it into parts, into equal parts. Good, and now we're saying it's 2/6. It's 2/6, as Quaid said. So it's actually less than 1/2. So now we've only shaded 2/6 of this shape. So from this part, which is just what we had before, we can see that 2/6 is shaded, and so that's actually less than 1/2. Great. It's 2/6 because I have 6 equal parts, 2 of which are red, and so it's 2/6 that is shaded. If you combine the red side compared to the white side, it makes that 75% of wow. We're going into percentages, sir. Woo, my children are way ahead of me today. All right. So the last part, go ahead, sir. We're gonna look now, the last part, the next part of our presentation we're gonna look at now would be what is a benchmark that is shaded.
All right. So we actually have been
If you
using
combine the red side, compared to the white
benchmark.
side, takes
So in benchmark,
5% of wow. We're going into percentages, sir. My children are way ahead of me today. All right.
give me 1 second.
We're gonna look now at the last part. All right.
Am I still being echoed? Can you type in the chat if I'm being echoed? Okay.
We're hearing
Oh.
you.
All right, good, fantastic. All right, so we have been using something we call, thanks much, called benchmark, right? So earlier, before, we would have said that we are using something less than a half, equal to a half, and in some instances, greater than a half. Now, what can you tell me about that said benchmark that we are making reference to? Can you type in the chat if I'm being echoed? Okay. Can you type in the chat to see, to tell me what do you think benchmark is? In your own little words, what do you think benchmark would be? Called benchmark, right? So earlier, before, we would have said that we're using something less than a half, equal to a half, and in some instances, greater than a half. Now, what can
Mr. Limi?
Oh, sorry about that echo. I was actually on YouTube. All right. So again, benchmark. Can you make up any definition of what you think benchmark would be? All right. Mr. Douglas said a benchmark is something that you use to compare. All right. Any more pointers that we can use? Anything else that we can say about benchmark? Anybody in the chat? You can type in the chat because we have muted the mics for now. Anything? All right. So let's go on. So when we're talking about benchmark, all right, so benchmark really and truly is us actually using as a point of reference. So we're using the half earlier as our point of reference and comparing it, as Mr. Douglas had said earlier, to something else, right? So it's something that we use to compare, right? All right. So what now if we are actually saying what is a benchmark fraction? So obviously we have been using a half for the majority of the session so far to actually benchmark fraction. So this is now a fraction that we can use, as Mr. Douglas highlighted, to measure against, even compare with other fractions. My bad about that. So we can also compare other fractions as well. Now, we can also identify it in our heads, in our minds. We can actually visualize these benchmark fractions, right? So anytime we speak about benchmarking fractions, we tend to compare to something else. And yes, it's a point of reference, as Galaxy is your 3-course said earlier, all right? Now, let's look at this number line. Now, where would I place this 3/5 on the number line? So I'm gonna have a number line right now on the screen, as you can see. So it's 0 all the way until 1. So you can say 0 would be your empty when we were referring to the gas tank earlier, and our 1 would be a 1 whole of a tank that is filled with gas, right? So we have this number line, and now I'm going to somewhat segment it or use intervals. And you're gonna tell me which one of these letters can I use to describe 3/5. All right, so I have A, B, C, and D. Now, where do you think 3/5 would lie or fall? You can type in the chat whenever you're ready. Where do you think 3/5 would fall? Would it be A, B, C, or D? All right. I got one response so far. Sir Douglas, Mr. Douglas. All right, Ava, Omar. Everybody's saying C so far. All right, nice. Lennon, you said D. All right. All right, the answers are coming in. Sarah, Johnny. All right. So benchmark is a standard against which things compare. Good, good. All right. So let's see. Now, one thing to note, can you tell me or even say to me in the chat, how many intervals am I using, starting from 0 all the way until I reach at 1? How many intervals? Do you count, or how many intervals can you see? All right, Douglas is saying 6 on the screen a bit. All right, so let's see. So I'm jumping from 1, 2, 3, 4, and remember I need to get to that 1 whole. So it's gonna be 5. So I have 5 intervals. And can you tell me anything about those intervals? Are they, I don't know, I'm looking for a particular word. Even though it might not be actually as the picture, the image is not drawn to scale. So that's a disclaimer as well. So yes, it's 5. Fullerton, St. Patrick's Primary. Yes, it's 5. All right. So we have 5 intervals and we have 5. I'm still looking for that word that I'm yet to see in the chat that I can use to describe this interval that I have on the screen right now. All right. Not getting anything so far. All right, they're the same. What other word? All right, good, fantastic. We can use the word equal. So they have 5 intervals that are equal. And what else can I say about that? It was mentioned earlier in the presentation about that equal part. What is so significant about that? What other terminology can I use, or other terms, sorry, that I can use to describe that 5 equal parts? Anything else I can use to describe that 5 equal parts? We said it earlier in the presentation. All right, 5ths. All right, we can say 5ths. But what? There's something coming at me, or should be coming at me. All right. So yes, it's equal, Aiden, good. And 5th St. Patrick's, that's all right. What about the denominator? What about the what you call it? Fraction family, or family fractions? Family fractions. Yes, okay. All right, nice. So everyone was saying C would be 3/5. And yes, you made a correction, Sir Douglas. All right, let's see. Let's see what I get. Let me just get this annotation off. All right. So yes, indeed. Yes, it's also a proper fraction. Good. Fantastic, Gianni. So it's 3/5 would be at that little section that we have at C, right? So we can actually say that 3/5, based on the number line that we just sketched in this sense, we would have said that C would be the best or the likeliest place that we could find 3/5 at. Now, how about another one? Let's try next one. So we have 5/6. Right, yes, it's a proper fraction as well. But I was really highlighting the denominator, but that's good that you can pick out that it's a proper fraction. All right. Now let's try 5/6. Now, how many intervals do you think I will be having or have on the screen right now on the number line? How many intervals based on this fraction, 5/6? What would I have as my interval? How many? All right, 6. All right, let's see if it's actually 6. All right, fantastic, Omar. All right, Aiden. All right, let's see. All right, let's count. So again, we start at 0. In this sense, we start at 0 on this number line. So let's count 1, 2, 3, 4, 5. And it doesn't stop right there. So we get 6. Now we have 6 equal intervals, and this can represent our denominator. So this one whole is divided into 6 equal parts, or 6 equal intervals, right? So let's see. Now you're going to tell me which letter again on the screen. Yes, it's 6. It's good. Fantastic. So let's look at the letters that I have on the screen. Let me just erase this. All right, good. I spoke too quick. Now, which one of these letters would represent 5, 6? Is it A, B, C, D, or E? All right. Everybody is saying E. All right, fair enough. Good. Gianni, Kido, Nathan, Omar, nice. King Weston, good. All right, E. All right, everybody said E. And yes, we're not going to use E as empty in this sense, but E is our answer. So let's see. So yes, E would be 5, 6. Let's see you try. Let's try another one. So 1/5. Again, we're using our number line starting from 0, which is our starting point, to our end point, which is going to be 1. All right. So this one now, where on the number line would I place 1/5? All right. Thanks everyone for selecting the answer. Yes, E is correct. All right. So on to 1/5. How many intervals, how many equal intervals will we have on the number line? All right, good. 5, 5. All right, 5. All right. And you can always go to your friend next beside you, and you can give them a high five if they actually got 5 to be the answer. All right. Let's see on the number line now. All right, let's count. So we always want to make sure that we have the correct amount of intervals based on the question that we have. So let's count. 1, 2, 3, 4. We don't stop right there. Carry on. We continue. So it becomes 5. So it's not 6. Carry on. It's actually 5. So it's 5 equal parts. And again, this can be symbolized by our denominator. What type of fraction would I call 1/5? What type of fraction would I call 1/5? Let's see if anybody remembers. What type of fraction would I call 1/5? What type of fraction would I call 1/5? Proper. All right, good. Fair enough. At least everyone is paying attention. Good. Dunkley, proper. All right. Gianni. All right, fantastic. Now let's look on the number line. Again, we're going to use some letters that we are accustomed to. A, B, C, D, E, etc. Right? So let's see which option you'll be choosing in this scenario. So we have A, B, C, or D. So we want to represent 1/5 on this number line that we have right in front of us on this lovely little screen. So which one would it be? Would it be A, letter B, letter C, letter D? Which one? And why? All right. Everybody said A so far. That's lovely. But why though? I mean, how do you know? How would you describe it in your own words? You can type in the chat. So everybody is saying A, that's lovely. Good. Savannah. All right, good. All right, now I want you to tell me, how do you know? Or what would you use to remember? All right, if you start at 0, that would be 0/5. And moving 1 space would be 1/5. All right, that's a great way of doing it. Or seeing it, right? All right. St. Patrick, you said D. Was that a mistake? St. Patrick's Primary, you highlighted that the answer was D. Was that a mistake? I've only heard from one individual so far, or one set of students so far, as it pertains to how did they get to the answer of A. Can anybody else tell me why did you select A? Why not D? Why not C? Why not B? Why did we select A? Anyone? Any takers on this one? All right, Dujan said we start at A, but D is 4 and we have 5, so we go right back to A. That's another way of exploring this number line. Anything else? All right, numerator is 1. All right, that's where we start. All right, good. All right, let's see if it's actually A, as we all said. All right, yeah. I mean, it's somewhat straightforward, I would believe, since we did so much examples. All right, and because it is a unit fraction. All right. So you're moving 1 unit every time, right? At every interval, yes? All right. Let's see this last one. Now, where on the number line would I place 1/3? Again, what type of fraction is 1/3? What type of fraction is 1/3? All right, proper fraction. All right. All right, good, proper fraction. All right. Now, I don't have any A. Again, this is a little disclaimer that the image is not drawn to scale, right? So in this scenario now, in this number line, where would 1/3 be placed? All right. Everybody's saying B. How did you get to that B? All right. Yes, it's a proper fraction. Good. So some persons are saying B, some persons are saying C. What would you tell your classmate right beside you that got a different answer from you? How would you correct them? Or how would they correct you? Or how do you think they would correct you? Why would I select B or why would I select C as my answer to represent 1/3 on this number line? All right. I'm saying 50-50. All right, you can always type in the chat which school you're coming from, or which school you are actually at, and how many students you have right now tuning in. So the teachers, you can kind of do that for me, please, in the chat. You don't have to send it to me directly. You can just place it in the chat. So just a little disclaimer again. So, all right, we're saying B. So how many intervals, how many equal intervals do we have? Or how many equal intervals will we have on this number line? Can anyone tell me? How many? All right, 3. All right. But why 3 though? All right, why 3? What tells us that it should be 3? Why not 5? Why not 6? Why not 1? Why 3? Why the number 3? If you jump 1 space, you get 3. Okay. Anybody else? All right. Can anybody else tell me how did I got 3? Just type in the chat. Oh, 33 students. All right, Miss Sarah. Because there are 3 loops. All right. Well, that's another word for intervals. Yes. All right. Good. Keep them coming. Keep responses coming. All right. Mrs. Francis says yes. There are 3 intervals. All right, Mrs. Francis. And our denominator is 3 as well. So I think that's from Clancarty Primary, if I believe so. All right. So let's just check it. Again, disclaimer. The image is not drawn to scale, but we're using the intervals to represent this fraction. So let's jump from the 0 until I reach at B. Again, that's 1. Then I jump again. Yes, even though the jump might be so far, again, this image was not drawn to scale. So I have 3 intervals. So the 3 intervals would basically be represented by my denominator. So I have 3 equal parts, or 3 equal intervals, or 3 equal loops. So starting from 0, and I jump 3 times until I reach at 1. So do you still believe that your answer would be the same? Do you think you're gonna switch from C to B? Are you gonna switch from B to C? Which one? You think you're gonna switch from your answer of B that you got earlier to C, or you want to switch back from C to B? All right, no, sir. So what are you referring to? Are you saying that you're not gonna switch from B to C, or what is that, Douglas? What? Oh, I won't switch. All right. So type in the chat again now. What would your answers be for this one? Which would represent 1/3? B or C? So one more time, doing a little call. All right. So let's see those answers again. I want to see one line of answers. I don't want to see any variations right now. I should only see one type of answers, one letter. All right, B. All right, good, B. Fantastic. All right. All right. I think we can move on right now. Fair enough. And if you don't know this not PowerPoint, but this session is on YouTube right now. So that's Region 1 Maths YouTube channel. You can always check it out, and I will try to provide the link in the chat shortly. Well, in a timely manner. So you can view the recordings of this session, and you can pause it at your own leisure at that point, right? So let's move on. So yeah, so we have B as our answer, which represents 1/3. Oh, we don't have any A, Savannah. We only have B and C. This is why I wrote it like that, to see if you were actually, paying attention. All right, cool. You made the correction. Good, B. All right. Now, we have a little race happening. I know that we love track and field and athletics. We like Usain Bolt, we like Shelley and Fraser Price, etc. So you're doing a race. Well, technically a race. So you have 3 friends, and the 3 friends are Mary, 3/4, Miguel, 4/8, and Harry is going to be 4/5. So you're playing that game of red light, green light. I know that you should be accustomed to that game. I mean, I used to play that game when I was younger, I would think. All right. So we want to find out who is actually winning. We don't want to find that out right now. We don't want to find that out right now. We're just giving this scenario to build up for later on, right? So again, I don't want any answers right now. We're just looking at the question to see who is winning and what are the questions. So the fractions tell you how much of a distance they have already moved. So they have a starting line and they're trying to end the race or trying to finish to come first and etc. In order to get a medal, depends on the section of the race that they're in, whether it's heats or finals, right? So we want to see if you can actually place your friends or these persons on a number line to show where they are between the start and the end, or the start and the finish, right? So again, we're not looking for any answers right now, right? We're actually just introducing this question right now, all right? So you can take a little picture of it, and then we'll go back to it later down in the session. All right? All right, cool. All right, I'm seeing some answers, but we're not going to look at those as yet. But let's see if you actually change your mind when we're actually going through it, right? So keep those answers, write them down in your book, write them down somewhere, write down these fractions, and let's see if you keep that same response that you had earlier, right? So again, it's not about the answers right now. It's just about introducing this scenario to us, right? Now, I think Quade Douglas had said that we use benchmark fractions to compare other fractions, right? So we're going to do some comparing fractions. Now, what signs or symbols did we mention earlier? You can type in the chat that you think we'll be using in order to compare fractions right now. Do you remember anything that was said earlier that we would be using to actually compare fractions? All right. Can you tell me what those signs mean? Because I can't read all of that right now. Just tell me. But I want you to unmute your mics, but I'll just leave it as it is right now. So more than and less than. All right. Anybody else? What else can I say besides more than and less than? How else can I say those terms? All right. Equal to. We have the equal sign. All right. Anything else? All right. More than, less. Okay. Any other sign that we're not sign, but any other terms that we use for more than? What else do we say when we have more than? I have more than you, but what else can I say? Or what else could we say? All right, and not, oh yes, good Dunkley. So yeah, greater than. All right. All right, cool. So we have greater than, right? So when we are using, remember, we're actually using benchmark fractions. So we're not gonna do, this is just one of the strategies that we can use to compare fractions, greater than. Good, fantastic. So this is just one of the strategies that we can use to compare fractions. There are multiple strategies out there, but we're just focusing on using benchmark fractions, sorry. So we normally have a guide when we're comparing fractions. And now that guide, as you can see on your screen, would be our denominator. And you might think of it as saying, well, why am I using my denominator? Why not the numerator? It's the number at the top, as you would say, right? So we tend to use the denominator for a guide when we're comparing said fractions. Now, there are some steps or some conditions that must be met in a sense, and we're going to look at those. So again, we were using a half as our benchmark from earlier in the session. So we're going to use a half. So how do we identify half of any whole? Can anybody tell me, how would I identify half of any whole? How would you say that to me? In your own little words, you can type it up, right? In your own little words, how do you identify half of any whole? What do you normally say to yourself? What are you thinking about? Again, how do you identify half of any whole? All right, it's a divide by 2. Why 2? Why not 3, 4, 5? Why not a million? Why 2 of everything? All right, 2 equal parts. So that's how we identify that little half. That's one of the ways that we can identify half. All right. You said it's because it's even, Dujan. Well, I mean, 4 is an even number. 6 is an even number. A million is an even number. All right. You can find half easier if you divide by 2. All right. Everybody's saying almost the same thing. At least 99.9% of us are saying the same thing, which is that we're gonna basically we have 2 equal parts. All right, good. Is everybody on the same page? Can I get a reaction from us? A thumbs up. Everybody's on the same page as what I'm saying right now, or what we are discussing right now. All right, cool. All right. All right. All right, good. Yes. All right. Now, we tend to look at the numerator and the denominator. But again, remember, we're using our denominator as our guide. So one thing to note, one of the conditions when we're comparing fractions using benchmark is that the numerator, yes, the numerator must be half the value of its denominator, right? And we're going to go through some examples right now. But this is just a statement that you'll see will come out more when we're doing some of these examples, okay? So again, we want to pay attention to the numerator. It must be half, well, not necessarily must, but in this scenario, we're using it as half of the value of the denominator. Now, let's look at some examples. So we have this fraction. Can anybody tell me this fraction? Write it in the chat. What is this fraction? What am I looking at? What number name can I associate with this fraction? How would I write it? The number, all right. Somebody says 5/10. 5/10, you really want it at 5/10? Well, when we're doing, yeah, I see everybody typing the fraction, but in words, okay? So we don't necessarily say 5/10 because we want to actually call out the fraction's name or the number name in that sense, right? So the correct way of saying it is 5/10, right? Not 5/10, not 5/10, but 5/10 with a THS. All right. Now, what digit is in the numerator? What digit is in the numerator? 5. All right. What digit is in the denominator? The denominator now. What digit is in the denominator? All right, 10. Now again, what does that tell me about my fraction? What does that 10 tell me about my fraction? What does the denominator, tell us about our fraction? How else can I describe that denominator? The fraction family is tens, all right? That's a good one. Douglas, you're on the ball. The 10 is a whole. You really want to say the 10 is a whole? You need to think about that one. All right, 5/10, that's another number name. 10 equal parts, fantastic. So it shows that we have 10 equal parts or how much it is cut into. So that one whole thing, that one cake, that one pizza is cut into 10 equal parts. So this represents our denominator. Now, let's speak about it a bit more. Remember that we're using our denominator as our guide. So, what can we say about the denominator and the numerator? Now, the denominator is 10. We said it earlier. But the numerator is actually half of the denominator. Is that true? Or is that a bit false? What do you say about that? Is the numerator 5 half of the denominator? True or false? You can write T or F to shorten it. T or F. True. All right. Everybody's on the same page. All right. Now, that 5/10, right? Is that what can we use as our benchmark? What is 5/10? Is it closer to something? Is it farther away from something? Is it greater than something? Is it less than something? Or is it right in the middle, as we would say? What about this 5/10? Is it greater than a half? Equal to a half? Less than a half? Which one is it? Close to a half? Which one do you think? It's a half, all right? We're using a half, all right? So again, is it greater than a half? What is it? Is it greater than a half, equal to a half, or less than a half? All right. So again, one of the benchmark fractions that we are using right now, yes, it's equal to a half, right? So one of the benchmark fractions that we're using right now is a half. That's what we've been using from the get-go, right? So this is half, this 5/10 is actually in the middle, as we would say, or equal to a half, right? Now, let's check another fraction. And I want you to tell me the fraction name for this, number name for this fraction. All right. So this fraction, and notice the question mark, or the question, is this fraction greater than or less than a half? Before you even think about all of that, how would I represent or say that number name in words? That fraction that I have on the screen right now, how would I say it in words? That number name, all right? So I'm not looking for the answer yet. I'm just asking what or how would I write that fraction in words? All right, you say a mixed fraction. All right, everybody's saying 3/10. 3/10, good. So 3 tenths. So which digit represents the numerator? Which digit represents the numerator? Which digit, and it's tenths with a THS, which digit represents the numerator? All right. All right. Now, again, we're looking at the numerator. What can I say about the numerator and denominator? Yes, some persons will say that the denominator is greater than the numerator. All right. Besides that, what else can I note from this? Again, we're using benchmark fractions, and everything is actually at the top of this screen that you're seeing right now. So again, the 3 and the 10, the numerator of 3 and the denominator of 10. What can I say about the numerator? Is the numerator equal? Is the numerator half of the denominator? Is it less than the denominator? Sorry, less than half of the denominator? Or is it equal to? Which one do you think? And how do you know? How do you know? All right, most persons are saying less than a half. But how do you know it's less than a half, the numerator? It's less than half of the denominator. Good, Dijon. All right. So the denominator is 10, right? And half of 10 is how much? How many groups of 2s do you get in 10? Or do you have in the number 10? How many do you have? 5. All right. And obviously, looking at this numerator, it's less than 5, right? So we can actually say that this is indeed, this fraction is what? Greater than or less than a half? No, you can give me those answers. Less than because it's 5 tenths is half, and 3 is less than 5, then it is less than good. It is not half of 10. All right, good. All right. So again, final question. Well, not the final question, but is this fraction greater than or less than a half? Is this 3 tenths greater than a half or less than a half? I think Douglas had made a good point. So that's one thing to know. Less than. Less than what? You need to tell me less than what? You can't just say less than 0, less than 5. I don't know. What are we using as our benchmark? We need to say less than half, sorry. All right. Good, good. Less than half, good. All right. Now let's look at this other fraction. How would I say this fraction, this number name? How would I write it in words? Not the answer. How would I write it in words? How would I write this in words, this fraction? 6 tenths. Anybody else? All right, good. They're coming. Fantastic. They're coming along. All right. All right, nice, nice, nice. 6 tenths. THS, not with a TENS. Right? Tenths with a THS. All right, good. All right. Now, just by your observation, or even just by us doing some examples earlier, would you think that this fraction of 6 tenths is greater than or less than a half? Is this fraction of 6 tenths greater than or less than a half? All right. You're saying that it's greater than a half. All right, not bad. All right, they're coming. Keep them coming. All right, Lennon. Greater than a half. Greater than a half, all right. All right, so everybody's saying greater than a half. So let's see how we got that, or how did you actually get it, all right? So the numerator is greater than half of the denominator. So again, the denominator is 10, and half of 10 is gonna be 5. So that's 6, as Douglas had said earlier. In this scenario, in this case, 6 is greater than 5. So hence, this fraction of 6 tenths is actually greater than a half. All right, good. All right, nice, nice, nice. And you need to say greater than what? Because you can't just say greater than, right? You have to compare it to something, and this is why we're doing the benchmark fractions using a half predominantly. All right, everybody's on the same page? Can I get a reaction out of everybody? So, can I get a reaction? Let me see. Thumbs up, etc. Even if you want to wave your hand or give me a high five, I'm giving you a high five too. All right? All right, cool, nice, nice, nice. All right, let's continue. So we're still in comparing fractions. So again, we're using a benchmark, and we're using a benchmark fraction of what? What is our benchmark fraction? What have we been using all this time? Can anybody type it in the chat? All right, half. All right, all right. All right, cool, half. Everybody's saying a half. All right, now we want to, the rectangular box, or well, rectangle, sorry. We want to put or place one of those signs or symbols in between a quarter and 3/4. Now we have the greater than, or, sorry, the less than or greater than sign. Now, which sign would I need to put right here for it to be true? Would I put less than? Would I put greater than? And again, how would you know? What would I use? What should we use? What can we use? All right. Can you tell me what that sign means though? Write it in words as well. So when you write the sign, I want you to write it in words as well. All right. All right. So how do you actually know that this is, I don't know, less than? How do you know? What can I use to tell us? Or what can we use to tell us? Why is it less than? How did you determine all of that? Yes, I'm seeing the answers, but I'm not seeing much explanation. All right, 3 is bigger than 1. But what else can I use? What did I use earlier? Oh, what did I use earlier? Again, all right, the numerator is less than the other. All right. So remember that we're using our benchmark. Yes, Nathan, our denominator. We can use our denominator as well. All right, compare the numerators. All right, good. So we have this representation of a quarter and 3/4. So how many equal parts is a quarter divided into? How many equal parts is a quarter divided into? 4. And likewise the 3/4, right? And you can obviously use this pictorial representation to actually show you that the 3/4 is actually more than the quarter, right? And again, we can use our benchmark, a fraction of a half, because the denominator is 4, and half of 4 is gonna be 2, right? So the quarter, it's not really at 2, so it's actually less than a half. And the 3/4 now, as someone said earlier, it's closer to 1 whole, right? But it's also greater than a half. So this is why we can actually write a quarter is less than 3/4, all right? All right, let's see. We have some more, well, we have some trickier ones coming up. All right, so that's the sign that I use, and that is the less than sign. Or we can say, how else can I say this? I have a quarter less than 3/4. Is there another way I can actually say that? Is there another way I can say, oh, I have a quarter less than 3/4? What's another way I could have said that? What's another way I could have said that? All right. Douglas, he said 3/4 is greater than a quarter. You're on it, man. You're on it. Fantastic. Good, man. Thumbs up. All right. So we can actually say that 3/4 is greater than a quarter or 1/4. So we can say 3/4 is greater than 1/4, right? All right, good. We're getting it. So far, so good. All right. Now, what if we had, well, we obviously had earlier like fractions, but we're gonna go in it a bit. So that was a pictorial representation that we can actually use to highlight this like denominators. Now, when we have like denominators, we're going to use the same thing of comparing using the less than and greater than sign. So we have 5/6 and 3/6. Again, we're using the benchmark fraction of a half. So we're going to be comparing the denominators. So not the answer yet. We're just going to work through this a bit. So the 6 in the denominator, is the 5, which is in the numerator, is it greater than half of the denominator, or is it less than half of the denominator? Which one do you think? The 5 in the numerator. 5 is more than 3. Where did you get that 3 from? Where did that 3 come from? Without looking at the numerators like that. We're deciphering it a bit, so we're bringing it in pieces. All right, so that would be more than or greater than. So the numerator of 5 is greater than or more than the denominator. So again, half of the denominator, sorry. So the denominator is 6, half of 6 would be 3. And obviously, the 5 is greater than the 3. So 5/6 right now is greater than a half. But let's look at the other fraction. The other fraction is 3/6. So as you can see, the denominator is 6 again, but half of the numerator, or the numerator is half of the denominator. So half of 6 is what? Half of 6 is how much? All right, 3. So the numerator there is 3. Now, how would you say that now? Because I mean, what am I saying? Is 3/6 equal to a half, less than a half, greater than a half? What is it? Is 3/6 greater than a half, less than a half, equal to a half? Which one? You can type in the chat. Which one do you think would be more applicable? All right. Equal to a half. All right. Anybody else would like to write in the chat? All right, good. All right, equal to a half. So the 3/6 is equal to a half. So which one do you think is greater? The 5/6 or the 3/6? Based on using our benchmark of a half. All right, I'm seeing everybody writing that good. All right, so let's see. So 5/6 is indeed greater than 3/6. All right, so again, 5/6 is greater than 3/6. Is there another way I could say that or refer to that statement that to make it true? What's another way of writing 5/6 is greater than 3/6? What's another way I can actually say that? Is there another way I could write that? 5/6 is greater than 3/6? No, all right. All right. So 3/6 is less than 5/6. All right, good. So that's another way of writing it, right? And somebody actually said, oh, Nadine had said 5/6 is greater than a half. All right. I see that you're using equivalent fractions. That's good. Even though we're not doing that right now, it's still good that you could simplify that fraction or reduce that fraction. All right, good. All right. So we can say 5/6 is greater than 3/6, or we can say 3/6 is less than 5/6, right? Whichever way we can write that one. Now, we have been doing like denominators. What about unlike denominators? Again, we do not want the answers right now. we're trying to do it piece by piece, right? To make you, everyone understand it a bit better. So again, the answers are not important right now. So we have 3/8. So we have 3/8. What is the denominator in 3/8? What is the digit in the denominator for 3/8? What is the denominator for 3/8? All right. Oh, all right. 8. All right. Cool. Now, what is half of the denominator now? Half of the denominator. How much is that? 4. All right. And we see that we have 3 at the numerator. So 3 is what? Is the numerator greater than half of the denominator, or is it less than half of the denominator? Which one do you think? All right, it's less than. Let's see. All right, so the numerator is less than half of the denominator. And yes, Douglas, we need to say less than half of the denominator. We can't just say less than half. We have to say less than half of what, right? So it's less than half of the denominator. So 3/8 is less than half, right? So we can actually say that now, that 3/8 is less than a half. Now, let's look at this 3/6. So for this 3/6, what would be our denominator for 3/6? What would be our denominator? 6. And what do you notice about the numerator? What do you notice about the numerator now? Can anybody tell me in the chat what I can use, or what am I noticing about this 3? This 3 is equal to half. Remember, you need to say half of what? Half of the denominator. Yeah, right, cool. So the numerator is half of the denominator. So again, we have 6 as our denominator, half of 6 is 3. So we see that the numerator is exactly 3. So we can say that the fraction of 3/6 is really half. As I think it was Nadine said earlier when she used equivalent fraction in that scenario to get a half, right? Now, what sign should I put in that little rectangle? Should I put greater than or less than? All right. Should I put greater than or less than? Greater than or less than in that little rectangle that I have. All right. Oh, all right. All right. So we have 3/8 is less than 3/6. Now, is there another way I can actually write that? Is there another way I can support that? How else can I write 3/8 is less than 3/6? How else can I phrase that to mean the same thing? So Douglas said 3/6 is greater than 3/8. All right. All right, good. Good. All right, let's see. So 3/8 is less than 3/6. So another way I can actually say that is that 3/6 is what? 3/6 is what? 2 3/8. Is it less than or is it greater than? All right. Is 3/6. Notice what I said, 3/6. Let me write it on the screen. What if I turn this around and wrote 3/6? I have the rectangle. Sorry for the bad handwriting. And I have 3/8. Now, what sign would I place right here? Would it be a greater than or less than sign? Greater than or less than sign. Remember, I'm referring back to the same thing over here, but I'm writing it another way. So what sign should I put in that rectangle? All right, greater than. All right, Nadine, good. And I want you to use that symbol now, use a sign now. I know I've been telling you to use words, but let's see the symbol now. What symbol should I write for greater than? The greater than symbol. What symbol? How does it look? All right. I see that we're still having a bit of confusion right there. So this right here is a greater than. So this is why we highlighted those signs and vocabularies at the beginning, because we want everyone to be accustomed to them so we don't make any mistakes right now, right? So again, this means greater than, right? So this sign right here means greater than, and this one over here is less than. Again, sorry for the handwriting. It's the best I can do right now, all right? So that's the difference right now between those two signs, right? Everybody on the same page? Do I need to check over anything? Oh, yes, but yeah. Yeah, I don't want it to be inverted. So let me not do that right now. All right. All right, cool. Nice. All right, let me just clear this screen. You can always take screenshots and it's on YouTube, so you can always make reference or make YouTube your, and as in Region 1's YouTube channel as your, what you call it, as your benchmark.
You can subscribe.
Yes, you can subscribe and like the page and all of that. And that would be a benchmark for your upcoming exams from grade 4, 5, and 6, because we have contents on all of those grades and more. Even when you go to high school, still have the page will still be up. All right. So let's see. Now we're back to the same question that we mentioned earlier, right? Now we want to find out again who is winning. So let's see. So again, not the answers, not so straightforward. So again, we have friends playing red light, green light, and we want to find out where on a number line or where would you place them, right? Who is first, who is second, who is third, who is closer to the finish line? We're gonna see. So let's see who is winning. So everybody's saying Mary. I'm seeing Harry. Mary, Harry. All right. All right, good. Everybody's saying Mary so far. I want to see one Harry. All right. Douglas is saying he's literally giving the positions. All right, let's see. Let us see. So we're gonna use a number line. We have been using number lines for the majority of this session. So let's continue using number lines, right? To see what will actually occur or happen. So again, we have this number line. So again, the 0 would be our start and our 1 would be our finish line, right? So when we finish the whole race, we're gonna see who comes first or who is closer to finishing that race, all right? So let's see. Now, the first one that I'll be doing, let's see. You can type in the chat. You're gonna tell me, based on the intervals that I'm gonna put up right now on the screen, if it is Mary. Again, let me go back. Mary is 3/4. So write it down in your book. Mary is 3/4. Write it on the board, teachers. Mary is 3/4. Miguel is 4/8, and Harry is 4/5. All right. I want you to remember those fractions and remember the persons that they belong to. Even though it will come up on the screen eventually, but let's see. All right. All right. Now, obviously, this would be 3/4. And how do I actually determine if this is 3/4? What on the number line did I do differently to indicate that this is 3/4? What did I do on the number line? What particular thing did I do on the number line to indicate that this is being divided into quarters? What did I do? What did I do differently? And what name would I attach to 3/4? What name would I attach as 3/4? Okay, Mary. But how do I know that it's actually Mary besides literally the 3/4 there? Let's say it was the 3/4 was not there. How would I know that it's Mary, not Miguel or even Harry? How do I know that it's actually Mary? What on the number line would I use to represent that? What on the number line did I use to represent Mary's, well, where Mary is? What did I do to the number line? There's a particular thing that I did to the number line to see. Or where would I put Mary? I kind of need to do something special. So what did I do? What did I do for this one? Nobody? Remember, we had divided or used intervals or loops. 1, 2, 3, 4. All right. So we would have used 4 intervals because the denominator is 4, and that indicates that I'm going to divide this number line into 4 equal parts. And then we would have written that 3/4 would be Mary's, that would be Mary's position on the number line, right? So let's see if you can figure out who this one would represent. So that's Mary. What about this one now? Would that be Miguel or would that be Harry? And how do you know? How do you know which one would I? Yes, Aiden? You can type in the chat. How do you know that it's Harry? How do you know it's Miguel? You have only 2 persons left back. So how do we know which is which? Is there anything different I did on the number line? All right, you're saying that it's Harry, but how do you know that it's Harry? Are you guys not hearing me? Tell me if you're not hearing me. Are you hearing me? Oh, all right, good. Victor, you said that, oh, internet issues. Oh, I see. So, yes, Victor, you said, let me go back to that. 8 intervals. So it's for Miguel. So remember, I think I should have written it somewhere because it's not on the screen. But let me just write it over here. So Miguel, I'm going to shorten that and write 4 8s. Harry was 4 5s. And Mary, obviously, Mary's on the screen. Oh, we're almost finished. Don't worry. Oh, all right. Now, you probably wonder why I divided into 4ths earlier for Mary. Again, the reason why we divided by 4ths is because we look at the denominator. And the denominator, which is 4, indicates how many equal parts I am going to loop or divide this number line in. So again, we start at 0. We go right here, 1. Then we go back here. Then we go back here. Then we go back here. So we have 4, what do you call it? We have 4 intervals. So this would indicate the denominator, right? So this is why we have 3/4. Or in other words, the denominator is 4. We divide by 4 equal parts. All right? So that's how we got that. I hope the individual that had said we never understand how we got to that would have seen that. All right? Now, again, the one with the 8s, the reason again is because we have 6 minutes. So in 6 minutes time. So again, we have 8s interval. So this is why we look at the denominators, that's a left back. We have 4/8 and we have 4/5. And if I'm using the denominator, 8 equal parts, so I look for the fraction that is being divided into 8 equal parts, right? So that person would be Miguel, right? So this one would be Miguel. Now let's see the last one. How much intervals would I have for Harry? How much intervals would I have for Harry now? How many intervals would I have for Harry? Anyone? All right, 5. All right, good. So I'm gonna have 5. And right there would be 4/5. I counted 1, 2, 3, 4, and then 5, sorry. So I count, and then I've gotten 5, right? 5 intervals are 5 loops on this number line to indicate Harry's share. Well, where Harry is. So most of us had said Mary. Some had said, oh, that should be the other way around. My bad. My bad. That should be the other way around. So this one should have been 3/4. My bad. So the 3/4 should have been before the 4/5 should have been after the 3/4. So that was the issue right there. So my apologies for that one. The annotations were off. Well, animations were off. So I apologize for that one. So we would have switched these, right? So Miguel would have been 3rd. And why is he 3rd? Because he's the last person. Well, he's the farthest away from the number line, from the finish line, right? All right. Now again, Mary should have been over here. So Mary would have been 2nd. And then Harry would have been 1st. So let me just redraw that for you all. Where is it? All right, so I'm gonna redraw it just to clear up any misconceptions. So when we would have the fourths, this is what we'd have for the fourths. We divide it into 4 equal parts. So 1, 2, 3, 4. So our what's her name? Mary would be 3/4. So this is 1/4. 2/4, or in other words, a half. Then we go to 3/4, right? So this would have been Mary, which would have been 3/4. All right. So that's Mary. I hope everybody's understanding that part, right? So then we would have continued and went on to, all right. Oh, so let me just get that back up. All right. So again, this would be 3/4. Now the other person would have been Miguel, right? So I would have further divided this line into 8 equal parts. As you see right now, let's count. 1, 2, 3, 4, 5, 6, 7, 8. So this would be 8 equal parts. So again, this right here would be 4/8. And this would be Miguel's. This is where Miguel would be, right? Then the next one, or the next individual, or you can say a half. 4/8 is basically a half because we have the denominator is 8 and the numerator is 4, which is half of the denominator. All right. Now let's look on the last one. So I have Miguel and Mary right there. So the last one now would be Harry. So Harry would be 4/5. So again, Harry would be 4/5. So how many equal parts I said we would divide it into? Nadine had said earlier 5, and others had responded to say 5. So, yeah, you can draw this one as well. So we have divided into 5 equal parts. So we have 1, this right here, and we move on. But let's count if we have 5 parts. Again, the diagram is not drawn to scale. So let's count 1, 2, 3, 4. Sorry, 4 right here. And then we have 5. So remember that we want 4/5. Even though, again, the diagram is not drawn to scale. So the 4/5 would be a bit further off, right? Because I would have misplaced this one right here. Should have been over here. Yes, this is why I don't draw that much. Because, yeah, it's hard to actually disseminate this thing. 1, 2, I don't want to put the half right there. 6, let me put it right about right here. Let me just delete that. Right, and then I would have had another one right here. Again, it won't be drawn to scale because I'm not using a ruler, as you can see. So yeah, so again, this would have been Mary, and then right here at this point would be 4/5. So this would have been Harry. All right, so again, Harry would be first, Mary would be second, and finally, Miguel would have been third. So we would have come, you can draw this off in your books, and remember to use a ruler, unlike myself, who didn't get to use a ruler, but try to draw this off or sketch this off to see or know who is actually going to win, right? So again, Harry is the winner, and that's really it. So Harry would be first, Mary would be second, and Miguel would be third. All right.
Okay, so we've looked at a number of things so far. We've looked at a number of things so far. We've looked at how we name fractions, at how we use a benchmark. Today's benchmark was a half. It could have been other benchmarks, but today we used a half. You could have used a quarter, a third, whatever benchmark you chose. And benchmark is something you use every day. So for instance, maybe you notice that mommy doesn't always measure the rice she puts in the pot because she has an idea of how much rice she needs for everybody's meal. Or she might just say, oh, I know about how much it is. So sometimes because we have an idea in our mind, we have a visual image, we have a mental picture, we have a point of reference, we can use our point of reference as a benchmark in order to do other things, and we can compare. No, I need a little bit more, I need a little bit less, and so on. And that's what we did today in using our benchmark fractions to compare to know whether Harry was first, second, or third in this 1, 2, 3 red light game. So we want to be using this more and more as we go forward, and it's a tool we want to be using as frequently as you can. So we hope that you've gotten a benefit from today. But before we go, we please, Winwood Road, St. Peter and Paul, Clancarthy, and I believe the other one was St. Francis Primary. Mrs. Mundell, I think it's Miss Edmond, all the teachers, could we please share the number of students present for today's workshop. We're going to end shortly. And finally, what I'll ask you to do now is to fill out our evaluation form. We needed to do that as well so that we